So here we are. All right. Summation notation with Riemann sums. Okay. So we'll start with summation notation. Okay. Have you ever seen this in any of your classes before? Should have been in Algebra 2. Okay. Where you start at 1 and you plug a 1 in here. 2 times 1 is 2, minus 1 is 1. Then the next number is 2. 2 times 2 is 4, minus 1 is 3. Then the next number is 3. 2 times 3 is 6, minus 1 is 5. So it's 1 plus 3 plus 5. Because you stop when you hit 3. Okay? So 1 plus 3 plus 5. And so then when you add them up, you get 9. Okay? So that's summation notation. Now, we're going to use a summation notation to find our rectangles, okay? This will be the height of one rectangle. This will be the height of the second rectangle. This will be the height of the third rectangle, and so on. And we'll use a consistent width. We'll take width times height and find the answer, okay? And then we'll get into the limits later. Okay, so here's another example. If we start at 0 and go to 2, put in a 0, do the math. Put in a 1, do the math. Do the 2, do the math. So you get heights of 5, -2, and 1. Now, if the widths are all the same, you can do the heights all together times the width to get all the areas of your rectangles. Because if you do the distributive property is the height, the width of the first one, the height, the width of the second one, height and width of the third one. Okay? So if you do undistributive property, you just have to add up all the heights and take it times the width to get the answer. Okay? So, what would this be for summation notation? Now, the one we're putting in for what? M. Do we do anything with K? No. So this is 8K minus 6. The second one is 8K minus 12, and so on, which is this answer. Okay? Summation notation. So you'll have to learn how to use summation notation first before we get to the really hard stuff. Okay? Here's the answers. Which one of these work? Or do both of them work? Or do none of them work? So we try them. Put a 1 in here. You get 5 minus 8, which is -3. That 1 works. Then put a 2 in here. 5 minus 16 is -11. That works. And put a 3 in here. 5 minus 24. Wait. 5 minus 24 is -19. And put a 4 in, and you get -27. So that one works. Then you try this one. 6 times 0 is 0, minus 3 is -3. 6 times 1 is 12, minus 3 is, well, 9. That doesn't work. So this is the answer. Okay. All right. So here's an integral, and we want to approximate the area underneath that function from 0.5 to 3.5 using Riemann sums. So if I decide to use a right Riemann sum, my rectangles will look like that. Okay? This is a right Riemann sum with 4 equal subdivisions. Okay? Now, 4 equal subdivisions, I wouldn't choose 4 equal subdivisions if it was up to me. Because 0.5 to 3.5 is how far? 3 divided by 4. Each of these are 0.75 wide. Now, does that work? Yeah, that works, but it's not so nice of numbers when you're working with it. So to find the area of the 1, the 2, the 3, and the 4, we have to figure out where we are. Well, this first time, we're at 0.5 plus 0.75, or 1.25. The second one, we're finding the height at 2. The third one, we're finding the height at 2.75. The fourth one, we're finding the height at 3.5, okay? And we're plugging that into the square root, and then each of these is 0.75 wide. So the Riemann sum, how can that be written? Okay, well, I already explained the width is 0.75, and the height is what you get when you plug it into the formula. Okay, so you take 0.5, where we start with, plus 0.75 times I, the first number of our sum. Okay, so if you put in a 1, our first number will be at 1.25. So you're taking the square root of 1.25. The second one, you're taking the square root of 2, because if you put a 2 in here, 0.5 plus that, which matches the 2, which I set up there. Okay, and so on. So it's coming up with this formula is the most difficult part. What fits in to make it work? Okay, so then if you take the width times the height, you get the area of each. Well, if you do a Riemann sum of this, that's what you get. Now, what this will turn into is going to be an integral from 1 to 4 of 0.75 times the square root of 0.5 plus 0.775i. That's a 4, or x in this case. And you're going to integrate it and find the smooth area under the curve, because an integral is what you get when you do the limit and all that. Okay? So you have to find the width of each rectangle. Okay, so you have to subtract the highest from the lowest and divide by the number of rectangles to find the width of it. Okay, and then if you're doing a right Riemann sum, we're going to take where we start and add that to it. If we're doing a left Riemann sum, we have to start at the starting point and then add, or we might use subtraction. The height is what we do when we put this thing into the function. Okay, so you have a width, which is our change in x, and our height is this, our function at that point. Okay, so left Riemann sum, right Riemann sum. Most of the time our left Riemann sum will start at 0 to help take care of some things. So this graph shows a Riemann sum. Here's a left Riemann sum. Which of these functions fits that Riemann sum? Okay, so we're going to go back up to here and figure it out. Okay, I've got 10 equal subdivisions that I go for a space of 2. So each one has a width of what? 0.2. It's 1/5 or 0.2. So our height will depend on where I'm at the time. Okay, at 0, I'm going to be at a height of 0. Here I'm going to be at 0.2. I'm going to put 0.2 into that function, square it, and then multiply by 3. And that's going to be my height, and so on. So my height is going to change as I go along with my summation. Now I'm using a left Riemann sum, so I'm going to start at 0 each time. Okay? So I'm starting at 0, and I'm going to end up at 0. Now to get this far, when I put in 1, I'm going to go 0.2 over times I. So 0.2 times 0 is 0. I'm going to be at 0. 0.2 times I, I'm going to be at 0.2. 0.2 times I for my second one, I'm going to be at 0.4, and so on. So this works for where I'm at. Okay, so 0.2i is going to be basically my x. So I'm going to take 3 times 0.2i, and I'm going to square it, and that's going to be my height. So, and then if I want to take my height times my width, it's 3 times 0.2i squared, and my width is 0.2. So if you multiply all this out, 0.02 squared is 0.2 squared is 0.04 I squared times 0.2. If you multiply 0.2 times 0.04, it'll be 0.008 I squared. If you multiply 3 times it, it'll be 0.024 I squared, which is this one. Because if we start at 0 and go to 9, that covers 10 rectangles. Okay? And that's how you find the Riemann sum of the left, or the left Riemann sum of this. Okay? Okay, let's do another one, because I know that's confusing. That's not the easiest thing in the world. Okay, I want, again, a left Riemann sum. So I'm going to start at 0. See how some of these start at 1 and some of these start at 0? I want to start at 0 when I have a left Riemann sum. I'm going to start at 0. So I equals 0. And I've got 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go to 7. Why go to 7 if I just counted 8? Because you count 0 as a number. 0 is my first number, 1's my second number, and so on. So I got to go up to 7. Okay? So I want to start at 1. So I have to add 1 to it to start at 1, right? Okay? It's going to be I plus 1. Now, if I want to go over, how far do I go over? Well, I go over 0.25 each time. Okay? So I'm going to go, so my first one's at 1. My second one's going to be at 1.25. My third one's going to be at 1.5, and so on. How do I involve an I in there so I go over 0.25 each time? Well, it's going to be 0.25 I plus 1. Because if my first I is 0, I'm going to be at 1. If my second I is going to be 1, 1 times 0.25 plus 1 is going to be 1.25, and so on. Okay? So now I get to be at 1, 1.25, 1.5, and so on. I put this in for the x of here. So now all of a sudden, I'm taking the square root of this plus 5. This is x, where I'm at. Plug it into the function, add 5 to it. This is my height. What's the width of each rectangle? 0.25. Okay? Then I look at their answers and see what they have. And they have ones that work for me. So 0 to 7, 1 plus 0.25 I plus 5 times 0.25. Must be that one. Okay, let's do another one. Okay, this one's a right Riemann sum. And so right Riemann sums, I start with 1, not 0. I start with 1. Okay, but now we got to end up at -3. Oh my goodness. Now I got to go negative when I start out. Okay, so I have a Riemann sum. I go from 1 to 5 because there's 1, 2, 3, 4, 5 subdivisions. Okay, I want to start out at -3. So I'm at -3, okay, times I in some sort of way, and I is 1, okay? But then I want to go up by 0.2 each time, okay? But if I go up by 0.2, so if I put in a 2 here, am I going to be at -3 if I have it written just like this? No. No, I got to be at -3, and then I got to be at -2.8, and then I've got to be at -2.6, and so on. So how do I get from one to the next to the next? That's the tricky part. Now, what you can do is come down here and kind of steal their ideas, okay, because it is multiple choice here, okay? So it says 1/5 of I plus 1. Let's see if that works. 1/5 of I plus 1. So, and that is inside the square root, so that's my x. So if I go 0.2 I plus 1, what does that do for me? Well, 0.2 times 1 is 0.2 plus 1 is 1.2. That doesn't get me to there. So then they say, well, what about plus 4? Well, that wouldn't get me there either. Because I'm working on, oh, this is the height. So the height should be 1 the first time under square root plus 4. All right. So I want to be at -3 with this somehow. So how do I get to -3? And I want to go over 0.2 each time. Well, if I would be at 0.2 times I, here, let's do it this way. So I want to go, what if we go I minus 1? 0.2 times I minus 1, 0.2 times 0, and then minus 3. Let's do it that way. So here I'd be at -3 if I put in a 1, because 1 minus 1 is 0, times 0.2 is still 0, minus 3 gives us -3. And then if I put in a 2, because that's the next step, 2 minus 1 is 1, times 0.2 is 0.2 minus 3 is -2.8. Put in a 3, and that works. So here's my function that I discovered will go in for x. So now I have to do the summation of I equals 1 to 5 of 0.2 times I minus 1 minus 3 under a square root plus 4, and then my width each time is 0.2. Now, that doesn't look like any of these yet, does it? Well, now I got to do the math inside, okay? So let's distribute the math. So it's going to be 0.2 I minus 0.2 minus 3 plus 4. So it's going to be 0.2 I minus 0.8. Did I do that right? Plus 0.8. Okay. So so it's the square root of 1/5 or 0.2. Yeah, let's just go 0.2. 0.2 times I plus 4. If we do it that way, times 0.2. Now, do I have a 1/5 times I plus 4? I think it's this one, but I don't know where I screwed it up. Because I must have screwed it up some. Shh. 0.2, negative 0.2 minus 3 is negative 3.2 plus 4 is 0.8. We're at negative 0.2 minus 3 is negative 3.2. Negative 3.2 plus, oh, that's on the outside of, no, that's on the inside of my square root, which is 0.8. So if I look at this, 1/5 of 1 is 1/5 plus 4 is not going to be, ooh, yeah, it is going to be probably where I need to be. because 1/5, so it's going to be 4.2. The square root of 4.2 is, nope, not 1 point that. So it's definitely not this one. I figured this out earlier today, and it wasn't, and I've got something screwed up here. Right here, 0.2, if we put in a 1, we get 0. Oh, no. I shouldn't have the -1 in here. So 0.1 times 0.2 is 0, minus 3 is -3. And then 0.2 times 2 is, no, I need the -1. Because if I went 1 minus 1, 0, 0 minus 3 is -3. 2 minus 1 is 1, times 0.2 is 0.2, minus 3 is 2.8. So this is right. Put that in for x, plus 4.
Now you don't need -1 because it's the right.
Oh, it's the right Riemann sum, so it's at 3.2. Yeah. So I don't need the -1 because I'm doing the right Riemann sum, not the left. So I get rid of that 0.2, so that becomes 1, and then it becomes this one right here. All right, right Riemann sum, not left. Thanks for fixing that, because I was, all right. Midpoint Riemann sum, this is the last, nope, not quite the last one. Midpoint Riemann sum. Okay, so we're 4 equal subdivisions from 1 to 5. So, if I want the midpoint, I want to be at 1.5, then 2.5, then 3.5, then 4.5 to do with my I. So if I equals, and it starts at 0, so 0 times, so if I'm taking 0 times something plus 1.5, 1 plus 1. So it's 0 plus 1.5 to get to the first one, 1 plus 1.5 to get to the second one, 2 plus 1.5 to get to the third one, 3 plus 1.5 to get to the fourth one. So that's what I is there. So it's I plus 1.5. So it's I plus 1.5 cubed over 2 is my height. My width, these are each 1 wide. Okay? Riemann sum, 0, I equals 0 to 3. Okay? Well, the 1 basically disappears because 1 times anything is that. So I have to go I plus 1.5, which is I plus 3 halves divided by 2, this one. And then finally, a right Riemann sum with 10 equal subdivisions from 2 to 7. Okay? So if we start at 2, and it's a right Riemann sum, so we're actually starting at 2.5. So when I equals 1, we're at 2.5. When I equals 2, we're at 3. When I equals 3, we're at 3.5. When I equals 4, we're at 4. Okay? So, how do I get from there to there? Well, it's 2 plus I times 0.5. And then 2 plus I times 0.5. When I is 2, that would work. Okay? And so on. So I want to go 2 plus I times 0.5. And then it's 1 over that plus 2. There's my height. My width is 0.5. Now, that doesn't look like any of them really, does it? Now I have to distribute my 0.5 through there. So if I distribute my 0.5, 0.5 is the same as 1/2. So if I distribute my 1/2 through there, I have 1 over 4 plus, and then 2 times 0.5 is 1 times I plus 1 if I distribute it through, which 4 plus I plus 1 is this one. Okay, Riemann sum. You might have to spend a little time outside of class this weekend working on some of this. Okay, there is study hall tomorrow morning, so feel free to stop by my room during study hall, even though I would expect every one of you guys probably has an open first period. Well, no, you have band and choir, but those of you with study hall have an open and probably want to sleep in. So however you do it, I'll be around to help here.